Good day, welcome to this video. The topic we'll be discussing today is motion. Now, this is an introductory video to motion. There will be several segments of other parts, but this will be an introduction. Now, what is motion? Motion involves the change of position of a body with respect to time. Now, motion is caused by force. Now, the force which causes motion can be in two forms. It can be in contact, that is the contact force, and non-contact force or force fields. Now, under contact force, this involves direct contact with the object, as it implies contact force. Examples include pull, push, tension, etc. Example, if this is our body and a rigid body and a string is attached rigidly to this body and I'm pulling it this way, I'm applying a pulling force. While on the other hand, if I'm pushing the body with respect to the base, I'm going to have to be in direct contact with the body. Now, in terms of push, I'm not going to use a string, but I could use like a rigid pull. For instance, let's assume the body is a very hot body here, and I have, instead of a string now, I have a rod connected to the body. I can use this rod to push it in that sense. Now, under force fields, there's no contact, it's a non-contact force. It also causes motion. Example of such force fields are gravitational force, electric fields. Look at force fields as, for instance, if you've been close to fire, an oven, you don't have to come in contact with fire for you to feel the heat. You just need to be close to it. You need to be close to its area of effect for you to experience what it causes. Similar with force fields, as long as the body is in a region of space where the force fields can exert the force on the body, it can still cause motion. Now, quickly, we move on to types of motion. Now, we're going to discuss 4 types of motion. 1. Random motion. Feel free to take notes. Now, random motion just simply refers to haphazard motion that is just done randomly. An example of this is Brownian motion. Now, number 2, translational motion. Now, under translational motion, this just means a rigid body moving from one point of space to another point of space without rotation. So it is a form of linear motion that is done without rotation. There's no rotation involved. Example, if for instance I go from distance A to distance B, without rotating, it is a translational motion. So also, if you have a diver, let's say jumping from the diving board, he or she is going to move in such a way that person, assuming person is not rotating, yes. So this is also a translational motion, basically linear motion without rotation. Now we come to rotational motion. Now, rotational motion deals with all points of the body moving in concentric cycles. Now, the term concentric, a concentric circle or concentric circles, assuming this to be my center of my circle, the center of my circle. Let's assume 0,0 as a position in space, and this is my circle. Now, this origin in red, let's call it A. Now, if circles are concentric, it means if I draw any other circle, its origin must also be at A, like that. While eccentric means they don't have the same centers. So that out of the way, rotational motion deals with all points of the body moving in concentric circles. Example, a rotating wheel. Sorry about that. Let's assume this to be a rotating wheel. Let's assume this to be the center, and this as our horizontal reference. This is the wheel, and let's assume it's rotating it in this direction. Now let's assume a point P over here. We'll see that P is also going to rotate concentrically with respect to the center of the circle. Now let's try and sketch a two-dimensional drawing of the wheel. So let's assume you have something like this. Now this is center. Now for rotating bodies, they usually have what is called as an axis of rotation. So also does the Earth have its own axis of rotation. This is axis. Let's assume this to be the axis of rotation of the Earth, and it's inclined at about 23 and a half degrees. So also example of rotating motion is the fan blade of your fan. Another example would be similarly as we used in translational motion, a diver, but instead of moving without rotating, let's assume the diver to be rotating in mid-air. Something like this. So this is an example of a rotational motion. Now lastly, we have oscillatory or vibrational motion. Now this is simply a periodic motion when a body moves to and fro, reversing its direction of motion and returning to its original position. So the motion is periodic. An example of this, to help us grasp the concept properly, is an example of a pendulum bulb. Originally, pendulum bulb is like this, but when displaced, we see it swinging to and fro. To go from point A to B, then back to A, and also from A to C and back to A. So it's to and fro. Another example of this would be, this means it's fixed to maybe a wall. So assuming this to be a spring, and the spring is attached to a mass, when we displace this, it will start oscillating to go up and down, up and down. This is another example of oscillatory or vibratory motion. Other examples include tuning fork, the diving board, again, diving board of diver. When diver is about to jump, diver you see diver jump on diving board a couple of times, and even after diver jumps off the board, you notice for some time diving board will oscillate, and that's another example of oscillatory motion.